Hello students, welcome to the next video in our new series, Equations of Motion 2. Now in the last video we were just introduced to the equations of motion, did a couple of worked examples, hopefully you did a whole lot of questions, got your head around the how to recognize which equation to use, how to recognize what you're given, things like that. And so we're going to push it a little bit further now and look at what's called vertical motion, and we're going to pretty much look at the dropped scenario. And so far all our equations of motions, or most of our applications, have been in the horizontal, things moving along railways or tabletops or running tracks. But now we're going to enter into the world of vertical motion. And this little diagram just shows you what we mean by vertical motion. Got a cliff, you drop something, it has vertical motion. Okay, now once we've done vertical motion, we're then going to do projectile motion. Now vertical motion can be not just dropping, which we're going to do in this video, but also throwing down, and, which is a little subtly different, also throwing up, straight down. Okay, and they're all called vertical motion. And they're all going to use the equations of motion because we're going to have acceleration. And most of the time the acceleration we're going to talk about is the acceleration due to gravity. Projectile motion, the next bit, is this sort of motion here, where you're not only having vertical motion, so it goes from a vertical height to a lesser vertical height, but you also have a horizontal motion. So it goes from here horizontally, which is equivalent to here, across to here. And so projectile motion is actually a combination of vertical motion and horizontal motion, and that's why projectile motion is a bit more complicated, and sometimes students have a little bit of trouble getting their head around it. But hopefully, because in the previous video we were looking pretty much as using the equations of motion for horizontal motion, okay, in this video and the next one we're going to use the equations of motions to work out vertical motion. Okay, if we get our head around that, we can then find it an easier task to combine it for projectile motion. Alright, so let's just look at vertical motion. Here we have a helicopter hovering, so it's got no horizontal velocity, it's just staying there. It drops a parcel, and this is like a time-lapse photo of the parcel falling through the air. And I think these intervals are at about half a second. Now you can see here that these intervals get larger and larger for each time period. So effectively it's travelling a further distance for each same time interval. And that's because it's accelerating, and it's accelerating due to gravity. Yeah? And we've used it before perhaps, but just to reinforce it, for us, acceleration, we would use the value of 9.8 meters per second to the minus 2 as our the rate at which an object accelerates. So here it's getting faster. What's actually happening, this is its displacement. Its velocity is increasing as it's falling, and therefore it can travel further because it's going faster in each time interval. Okay, and that's what's happening there. So that's our vertical motion in our dropped scenarios. So let's have a look at some questions and how to do them. So again, good practice, read the question a couple of times, get your head around it and be able to picture it, and then try and extract the information. And remember that we're looking for, when we read it, U, V, S, A and T. Again, good practice to write these down because we're trying to find them. Excuse me. So what do we got? A helicopter delivering supplies to a flood-stricken farm hovers at 100 meters above the ground. A package of supplies is dropped from rest just outside the door of the helicopter. So that's the scenario we were just looking at with the picture. Calculate how long it takes the parcel to reach the ground. So first off, let's see if we can recognize any information. The helicopter, that's not important. Flood-stricken farm, not important. In terms of physics, it's not. hovers 100 meters above the ground. there we have an S, and that's 100 meters above the ground. So if the ground was here, our parcel is up here. So we have to make a decision. Oops, I'm a bit leany there. If that's our start position, okay, now usually we would say in physics question that down is negative, okay, and up is positive. And that's a very important thing, because that's defining what will be positive and what will be negative in our equations. And so if we're starting with the helicopter and the parcel here at 0 meters, and the helicopter is 100 meters above the ground, what we should really be saying is that the parcel's going to fall minus 100 meters. Can we get that? Because this is our start position, this is our finish position. Even though we're told that it's hovering at 100 meters above the ground, because we're saying that this is our start position and it's moving in the negative direction, it's moving minus 100 meters. Alright, so that's our first piece of information. It's dropped from rest, so that gives us our u equals 0. Okay, so that gives us two things. What do we got? We've got minus 100 meters and we've got u equals 0. Now that's 2, but we really need to have 3 things to solve the question. Can we see any other information? We've got to calculate how long it takes. So that's just what we're after. We're just trying to find the time. Okay, so the trick here is to recognize that this is falling due to gravity. And as soon as it's falling due to gravity, we can use A equals 9.8 meters per second to the minus 2. But notice that this is also accelerating in the negative direction, and that's why we would also say that we're going to use minus 9.8 meters per second to the minus 2 as the acceleration. So we write here minus 9.8 meters per second to the minus 2. Now that's the hidden thing in this question, that once you tune into the fact that gravity's there, you get given it. So we now have our 3 things, and so now we can solve it using the equations of motion. But these negatives are quite important. Let's hope I explained that clearly enough, and let's just move on to where I've written it. Let's see. There we go. So notice here, both are negative. Now that's important because when we put it in, and we would recognize that in this case, because we want, what do we want? T. We want to use S equals ut plus half at squared. Fortunately u is 0, so that gets rid of that t. And we'll talk about some scenarios where what do we do if u is not 0, because then we would have 2 t's in the formula. We have to be very careful with our signs, so this is why I write down the next step and I put things in brackets. Okay, remembering that the square is the square of t, nothing else. And this becomes minus 4.9, so I've probably missed a line of working there. Hopefully you understand what I've done, because this times this becomes minus 4.9. This disappears, and so we end up with minus 100 divided by minus 4.9, and that's where the sign, having the correct sign, has been important, because that we can then take the square root of that and we get our answer, in this case 4.52 seconds. Oh, someone's drilling a hole in the background. Hopefully that's not too noisy. Alright, so that's one example. And this is how they've worked it out. Notice they've done a little bit different, and I probably wouldn't recommend doing this. What they've said is there's the ground, there's the parcel, it's falling that way, and they've decided to say negative is positive, and by consequence up, negative is positive, no, down is positive and up is negative. And you can do that. Physics, you can swap it. but I generally wouldn't recommend this because that just throws a little bit of confusion. We can do that a little bit later when we really got our head around these questions. And so the consequence of this is that over here they're just using 100 meters, and instead of minus 9.8 they're using 9.8, and the net result is exactly the same. Alright, but I would generally recommend that you don't use this, and you try and get into the habit of saying down is negative, up is positive. It just makes life a little bit simpler. Alright, so I'll get rid of that writing. You can pause and have a look at what they've done here, and then we'll move on. Okay, and they've also said the negative square root can be ignored here, as we are interested only in motion that has occurred after the parcel was released. Because we know when we take a square root of something, it could be, the answer could be positive or negative, plus and minus. You taught that in maths, aren't you? And that's why we ignore the negative. Okay, so let's do another example. So again, let's try and recognize it. Read the question. A spanner is dropped from a 6th floor window and takes 2.2 seconds to hit the ground. Calculate the height, which is s, from which it was dropped, and its impact velocity. What are we given? Well, it's dropped, so that's going to tell us that u is 0. It takes 2 seconds, so that's going to give us t, and because it's falling under the influence of gravity, we're going to use minus 9.8 meters per second to the minus 2. Okay, and I think I've got that appearing in a sec. Here we go. Alright, and there's our magical 3 numbers. So how are we going to solve it? Let's just pause for us. Let's just get rid of this first, and let's just pause for a sec. Right, I'm back. Hardly missed me. So what do we do here? We want to find the height. And so let's just get my pen here. What we need to do is for A, okay, knowing that we've got our 3 things, we want to find S. So we go, the equation we're going to use is S equals ut plus half at squared. S equals, now this is going to be 0 because u is 0, plus 0.5, just easier to put in your calculator if you do that. A is going to be minus 9.8, and the t over here is 2.2. Remembering that's the only thing that's squared, so we put that in and we get s. In this case, because we've got a minus there, our answer will be minus 24.2 meters, telling us that that is going to be down from its starting position, because again we've said that down is negative from our starting position. Alright, and next one, it's impact velocity, which is just a technical way of saying its final velocity. And so we could use v equals u plus at. We've actually got 4 things now that we put s there, so we could do it a variety of ways. This would be the simplest. V equals, putting in the numbers, again trying to get neat and tidy with our working, so that any examiner can see what we're doing. So I'm showing that I'm putting the numbers in the right place, and as a result of the minus there, we're going to get minus 22, and we put in the correct units, meters per second to minus 1. So that's how we do that question there. Alright, let's get rid of that now, and we can move on. I think a neat version will appear. There we go. This textbook uses 10 meters per second to the minus 2. Some states do that just to make the maths a little bit simpler, but it doesn't really help. I don't think so any. So their answers vary a little bit from ours, but that's how they did it. So in the next video, we're actually going to look at the next case. So in this case, we've just dropped things. In the next case, we're going to throw them down. How does that make things different? Well, you'll have to watch the next video to find out. Cheerio!